Okay, so we have the sequence. It is decreasing and bounded, and so it's a recursively defined sequence. A1 is equal to 4, and then AK plus 1 is defined in terms of AK. And we're given that it is decreasing and bounded. The decreasing and bounded tells us that the sequence has a limit. So remember, any bounded monotonic sequence has a limit. So that's the first thing that it tells us. It tells us that the limit, so we know that the limit as k goes to infinity of AK, this exists, and we're going to call it L. And now it's going to tell us the decreasing part is going to tell us a second thing in just a moment, but we'll come to that. I'm going to look at this. If this exists, I'm basically going to take the limit of both sides. And when I do that, if I take the limit of both sides, the limit as AK plus 1 goes to infinity. The limit as this goes to infinity is going to be L, and the limit of AK as k goes to infinity is also going to be L. So in other words, I'm going to get L is equal to 10 over 7 minus L. Now this is an algebraic equation, and I want to solve it for L. So the first thing that I'm going to do is I'm going to multiply both sides of the equation by 7 minus L. And this gives me L times 7 minus L is equal to 10. I'm going to expand this. I'm not expand, but distribute. And it's going to give me minus L squared plus 7L is equal to 10. Or if I rearrange, this is the same as L squared plus 7L. L squared plus 7L plus 10, minus 7L. Wow. 0 is equal to L squared minus 7L plus 10. I just added L squared and subtracted 7L from both sides. Okay, and so now I want to solve this for L. So you do this however you want to. I'm going to do it via completing the square, which is equivalent to using the quadratic formula. Okay, so now I'm going to do minus 49 over 4 plus 10. Well, if I want to get a common denominator, 10 is equal to 40 over 4. So I've got minus 49 plus 40, that's minus 9. So this now is minus 9 over 4. So minus 49 plus 40 is minus 9. So this is minus 9 over 4. And I have it set equal to 0 over here. So this tells me L. So it tells me L minus 7 halves squared is equal to 9 over 4. But when I take the square root, I'll get plus or minus 3 halves. Or this tells me L is equal to 7 plus or minus 3 over 2. Okay, however you come to this conclusion, I don't care. Once we get to this point, this is just a quadratic equation that you can solve in whatever method you feel the most comfortable with. So my two options then, if I take the minus solution, I have 7 minus 3. 7 minus 3 is 4. 4 over 2 is 2. The other option is 7 plus 3, that's 10. 10 divided by 2 is 5. Also, by the way, I don't know, you could also just factor this as well, or factor this as well. Again, however you want to do it is fine with me. So the two solutions are L is equal to 2 and 5. So in other words, the limit is either equal to 2 or 5. So I'm going to say L1 is equal to 2. And then L2 is equal to 5. And now we have to figure out from the information in the problem whether the limit is 2 or 5. This work here tells us the limit has to be 2 or 5. But if the limit exists, it has to be exactly one of those, not both of those. And now this is where the decreasing part comes in. So it starts at 4. The first term of the sequence is 4, and we know that it is decreasing. So if the sequence starts at 4 and is decreasing, then it's going down. Since 5 is bigger than 4, this can't be it. So this has to be the limit, since the sequence is bounded and decreasing. In particular, since the sequence starts at 4 and is decreasing, the limit has to be less than 4. It can't be greater than 4, otherwise the sequence would be not decreasing. But it is decreasing, so the limit has to be less than 4. So limit as k goes to infinity of ak is equal to 2 for this problem.